The null is the HO. It contains the equal sign. The alternative, the HA. It does not have an equal sign. It's the complement of whatever the null is. Work the claim first. The claim can be either one. The claim is the thing you're testing. You're going to find with the claim, we're going to pay attention to who's making this claim. If it's a manufacturer, they want to make it in their best interest. If it's a consumer, they might be challenging the manufacturer. Where I might be saying, God bless you, I might be saying my car is going to give you 55 miles to the gallon. And you drive my car and you say, I get 45 miles to the gallon. That's absurd. So as you start looking around, so people of your friends that buy this car, they have 48, 49, 50, 51. You're saying, I don't find anybody getting 55 miles per gallon. So you start testing. You get a sample group and you test. So your claim is, I'm not getting that much miles. I'm getting less than that. I'm at most getting that. The manufacturer is saying you're at least getting that. So it depends on who's saying this. And you're going to see when we test, it depends on if you want to reject or you want to fail to reject something. So, or if you just want to do the opposite. So you'll kind of get to see this, that little box that I gave you, when your decision, then you'll know which way to set up your claim. But these guys, I just want you to concentrate on your HO has an equal sign, your HA, no equal sign. Once we graph this, it's going to go off the HA, without the equal sign. So if you confuse these, everything that you do after this is wrong. So we start with the claim. This was what they gave us. This was the claim. So the claim has an equal sign. It's the HO. The complement of this, if it's not less than or equal to, it's greater than. That's the HA. Okay. Whatever they gave us was the claim. So in number 12, that's the claim. That the mean, and remember, we're at all different parameters here, and they're all population parameters. This is important that you remember the population parameters. There's no X's in here. So P is the population proportion. Mu, there's our population mean. Sigma squared, there's our variance. And plain old sigma, there's our standard deviation. These all have to do with the population. We're making a hypothesis statement against a population. We're testing it with our samples. Okay? So we're less than 128. If you like to, you can make a number line. Here's 128. It's open and it's less than. Its complement has to include this and be everything greater than that. If it helps you, put it on the number line. Okay. Your claim, remember, can be either one. The not equals is interesting. This says it's not equal to 5. So if this is not equal to 5, it could be anything else but 5, right? It could be this or this. It just can't be 5. So your HO comes in and says, what's the only number you're missing? 5. So your HO says, well, I'll be equal to 5. That's the only thing I want, 5. Not equal to means I want anything else but 5. For some odd reason, kids have trouble with the not equals. A variance, this is my population variance. It's greater than or equal to 1.2. Its complement is my variance is less than 1.2. The equal sign gets the HO. Okay? P is proportion. Population proportion. My proportion is less than 0.45, or 45% if you look at it. My complement of that is P is greater than or equal to. The one with the equal sign is the HO. You guys got all this? Okay? P is equal to 0.21. Proportion is equal to 0.21. P is not equal to 0.21. Okay? Now these were interesting too. See these guys. I like looking at graphs. So 17 through 18, you had to match them up with its graph. Now, back to your math skills. If something doesn't have an equal sign, it's an open circle. They didn't use a circle, they used a bracket instead. Did they use a bracket or just a... No, they didn't use a circle. They used an open circle. Sorry, that was me. Okay, so they used an open circle. So you're looking for the guy with the open circle in here. And its alternative is everything but that. If this is mine over here with an open circle, I want to close it and do everything opposite that. That's my complement of that. So 17 matches up to C, 18 matches up to D. Again, this was open. So you're going to close it and go the opposite. That's its complement. Not equal to means I just can't use this one. I can use everything else. So its complement, just use 3. For you guys that around here, does this make sense? Stephen and Katie, make sense? Okay. And that was all I gave it to, right? Oh, I did? Okay, thank you. Okay. 25 says a laptop manufacturer claims that the mean life of a battery for a certain model of laptop is more than 6 hours. Now, I'm the manufacturer. Would I claim that it is less than 6 hours? No. I'm, of course, going to claim it's more than 6 hours. I want you to buy this. The most annoying thing is when your battery goes out all the time, right? So if I tell you it's more than 6 hours and you start using this and you say, I'm not getting 6 hours on my battery, your counter is going to say it's less than 6 hours. But me, the manufacturer, you're getting at least 6 hours. It's more than 6 hours. So here's the claim. Claim does not have an equal sign. It's an HA. Its alternative one, sorry about this. This should say HO. Its complement is the HO. That has the equal sign. A company stated its shipping department, the number of shipping errors per million shipment is, thank you, sorry, is less than 3. Now, I'm the shipping company. Am I going to say I have a lot of errors? No, I'm going to say less than 3. You're going to challenge me and you're going to say, I'm finding a lot of errors in your work. I think you have more than 3. So, pay attention to like who's making these statements. Of course they want to say it in their favor. Statistics are meant to bend a little, right? So we start with this. This guy's our claim. Whatever is stated is the claim. The HO has the equal sign. It's its complement. A standard deviation, remember you're using the sigma. There's no X's in this. Of the base price of a certain all-terrain vehicle is no more than $320. Is this the manufacturer talking this, or the people buying it? Manufacturer. He's going to say no more than, it's less than. There's not a lot of variance between my prices here. Okay? So that's his claim, and this opposite, this is the HO. I don't know why it's over there. And that's the HA. And it's going to be really important because as soon as we hook these all together, the HA is our graph. And it's going to follow the tail of the HA. So it's really, really important that you get that down pat. I gave you the 30? Okay. 29. The company claims that its brand of paint has a mean drying time less than 45. Of course I'm going to say it's less time to dry. I don't want to tell you it's more time to dry. You're not going to want to buy my paint. So less than 45, it's his claim. The complement of that, greater than or equal to 45. And in a recent survey, 39% of college students own a credit card. This is where kids always have a hard time, on the equal one. It doesn't say is all the time to be equal, but they say own. Own is like having, is equal to a credit card. So exactly 39% have this. The opposite, not 39%. The equal sign is the HO. Good? Good. Okay. Hold on. So it's sometimes a little bit hard to like figure out how I'm supposed to show you this because we don't dwell into this. When you want to be 95% confident about something, there's a 5% chance that you're off, right? So that's kind of where our level of significance is. How significant is your error? Which is what I'm worried about. So to test the claim, we always assume that the null hypothesis is true, not claim, null hypothesis. So when you perform a hypothesis test, you will make one of two decisions. You will either say, reject the null hypothesis, or if you disagree with it, if you agree with it, you don't say, I think it's good, I like it, you say, fail to reject null hypothesis. These are the two statements that we will make when we judge a claim. Now, because your decision is based on your samples, you better have a really, really good sample that's a good representation of your population, or you're going to make the wrong decision. For instance, here's a good decision maker. Someone's on trial, and I'm the lawyer. So he's being accused of robbery. So he goes and he hires me as a lawyer. So the judge says, well, you're innocent until proven guilty. So we're going to assume that he's innocent. And we're going to set up our claims and do whatever. And we're going to say, okay, yes, he really is innocent. And we proved him not guilty. So we did a good thing, right? What if he really is innocent, and I did a terrible job defending him, and they proved him guilty? What happens? He goes to jail. Should he? No. So we made an error. How serious is this error?
Pretty serious.
Serious for who?
You gotta go to jail.
For the guy going to jail, right? It affects him the most. Does it affect the public? No. So it affects him the most. We just put an innocent guy behind bars. And for robbery, so my level of significance, should that be as important as if he was a murderer? Like if it was a murderer, or whatever his charge was? It's kind of like, okay, it's not armed robbery, so it's not all that important. Not it's not important. It's not all that serious, but I still put him in jail. Now I have a guy who's a mass murderer. This guy has been murdering people left and right. And he comes before the court, and I'm a fantastic lawyer, and I get him off. So he says he goes free. He's proven not guilty. So what happens to him? So he could go kill more people, can he?
Sure.
Is this a problem?
Yeah.
Is it more serious than putting the guy in prison that just committed a robbery?
Yeah.
Why?
Yeah, the robbery wasn't hurting anybody.
He wasn't hurting anybody. He's going to jail. Yeah, we ruined his life. But what about this guy? He's now out there. So my significance is probably a little bit higher on this, right? So there's certain things, certain type of errors that we can make based on our claims. We can claim something, we can test something, and then it's going to say, whoops, that's not so good. Look what you just did. Now there's a couple of good examples in here. Let me see if I have one. Here's the chart. I gave you this chart. Did I give you this chart on your paper?
Yeah.
This is our truth chart. There's 4 outcomes. I don't think I gave you this one. No, this is our type errors. So we always test HO. I did? Okay.
Yes.
We always test HO. And we assume HO is true. So here, HO is true. And we did not reject HO. It was true, and we didn't reject it. So we agreed with it. Basically, it's what it's saying. So we made a good decision. HO is true, and we rejected it. We made a bad decision. We made a type 1 error. Okay? HO is false. Not a good thing to happen. And we did not reject it. We should have, but we didn't. We made a type 2 error. HO is false, and we rejected it. We did the good thing. Okay? So the type 1 and the type 2 errors fall here. We're only going to deal with type 1 errors. That's our level of significance in here. And we're going to test it against the smallest allowable that will allow for this to happen. Here's a really good courtroom one that I was just telling you, like, kind of similar. I know this is a little boring, but you just got to kind of get the feel for the type 1 and the type 2 errors. So here are some potential choices and the errors that can happen. Choice 1. We cannot rule out the defendant is innocent, or he or she will be set free without penalty. Potential error. The criminal has been erroneously freed. Choice 2. We believe there is enough evidence to conclude that the defendant is guilty. Potential error. He could be innocent of what we convicted him of, and he's sent to jail. And the guilty party and the person who is guilty is still out there. Not only did we set this guy in jail, but the guy that is doing the crimes is still there, free to do more crimes. The result, although the seriousness of the two potential errors depend on the seriousness of the crime and the punishment, choice 2 is usually seen as more serious. When an innocent person is convicted and penalized, and the guilty people remain out there. Okay? Not only is an innocent person punished, but the guilty person remains out there. So if our statement was, he was innocent, don't worry about the healthy part. He was innocent, and we said not guilty, we made a correct decision. If he was innocent, but we charged him with being guilty, he had undeserved punishment. And somebody else is out there committing these crimes. So, if he's not guilty, and he was guilty, and we proved him not guilty, he's out there roaming the streets. So these are your type of errors that you're going to get. Another one that happens with that's serious is medical. Anything medical is serious. Anything like tires not working out is serious. It is true serious, but not as critical as this. So when we talk about, like, your tires didn't last as long, it's important, and they do have mistakes that we make, but not as serious as these guys. This one's a good one, too. I like this one, and I'll go back to the other one. The USDA limit for salmonella contamination for chickens is 20%. That's pretty high. A meat inspector reports that chicken produced by a company exceeds the USDA limit. In other words, they're higher than 20%, than the allowable 20%. What does that impact you with? What does that mean? If I set the limit at 20% and they exceeded their 20% limit, what does that mean? To you as a consumer, what does that mean? Say it again, Stephen?
You can have salmonella, so.
You could I could have more chicken that has salmonella than I'm allowed to, right? So and you're buying my chicken unbeknownst to you that the FDA did not approve me here. I'm above their limits. Even 20% is kind of high. So now, you got to be careful. So you perform a hypothesis test to determine whether the meat inspector's claim is true. He claimed, here's his claim, that we exceed the 20%. So how do I say exceed? Greater than or equal to? Greater than this, right? This is my what? HO or HA? HA. What's my HO? Okay, so let's see how this works. Okay, here's my statement. Here's my HO. Oops, just greater than. This is my claim. This is what the meat inspector is telling me. Okay, now, I can only test the HO. So follow this chart. I know it's tough. I know it's not exactly exciting, but let's just follow it through. I test HO. HO is this guy. I have less than 20%. I'm a store owner. The FDA said, the USDA said, I have more than that. But my HO says I have less than or equal to that. My HO says I'm within that limit. So now this becomes true. This is true. I really have less than 20%. But they did not reject my HO. They kept this true. Was that a good thing for me? They agreed with me? We say do not reject. Do not reject means the same as keep it. I accept it. So that is a good thing for me. It showed that that's right. You're right. I really do have less than 20%. Instead, they rejected the HO. If they reject the HO, they're saying that I have more than 20% contamination. What happens to my store? Shut down. The USDA said you exceeded your limits. I'm shutting you down. So me as the business owner, I lose money. I lose potential customers. It does not look good having that sign on my door. I've been shut down because of my salmonella poisoning here. My salmonella contamination. That does not look good for me. Even when I reopened and I proved myself that I didn't, it still does not look good for me. Now, flip side of this. Here's my HO. My HO says less than 20%. This was not right. This was false. I really do have more than 20%. So I really do have more than 20%, and they did not reject me. So now, the public comes to my store thinking, I'm all good, I'm within my limits, but I'm not. What happens? People can get sick. More people can be contaminated. I'm higher than the allowable limit. You don't know that. When you come to my store and you buy chicken, you don't know that. I could be well above my limits, but they didn't reject that statement. So even though the claim is an HA, we're always testing off of this guy. You see how the test works? And so now, who do I affect? Well, who does this affect? The consumer. Which there's more potential out there that people could get sick. People even die from salmonella contamination. People with autoimmune systems, deficiencies, older people get it easily. They could die from that. You could die from that. Salmonella poisoning, contamination. So, which one is more important? We look at the type 1 errors in this course. Type 2 errors is a whole course within itself. We do alpha for these guys, beta for these guys. We do the alpha testing. So when we set our level of significance up, it will look like this. This is an alpha test. This is going to affect this. Does it mean a lot as we do this? Probably not, because we tend to not see the real story behind all this. But when you're testing something, these errors are really, really critical. If you go into statistics and take more advanced courses, they'll work a lot with these, and they'll hit the beta errors too. We hit the alpha ones in our course, but the beta ones are equally important. So we kind of say this a little bit. I know this is not the most exciting part, but here's another good one. I love this one. A company specializing in parachute assembly, that'd be me, this is my company, states that its main parachute failure rate is not more than 1%. That's my claim. How do I write my claim? This is me, the parachute company. Less than P, less than or equal to 0.01. Is this my HO or my HA? HO. What's my HA? Greater than 0.01. Which would you rather have if you're coming to my company? HO. You don't want me to have more than 1% failure rate, right? That'd be terrible. So now, I'm testing my HO. My HO says I am less than or equal to 0.01. We only test HO. So now, HO is true. I'm a good person. It really is true. It's less than 1%. So they test this, and they did not reject this. So that was a good thing, right? Because it's true. I really do have less than 1%. So I'm cool. It is less than 1%. But someone came in and did a terrible test on me, bad sample, and they said, reject that statement. but I really do have less than 1%. So isn't this an error? What happens to me as a company? I'm going to lose business. People are going to think I have more than 1%, but I really don't. I'm going to lose business. I'm going to lose potential customers. That's a hit financially. I have to figure out how to get around that. I have to prove to the public that I'm safe again. Advertisements and all that stuff. Okay, flip side of this. This really is not a true statement. This really is not true. Even though I claim this, it's really not true. I lie. I really have more than 1% failure rate. So I claim this. So now it's really false. And they did not reject me. I really lied and nobody caught me. So now I have a type 2 error. Who is affected? The people that are jumping out of my plane, right? I have more than a 1% failure rate. Do they know that? No. That might be a criteria if you're going to jump out of a plane. I would hope you would ask that. What is your failure rate of your chute's opening? Because that's a major hit if your chute doesn't open, right? So that's something you should want to know. So now, people are coming to my parachute place, they're going to take their first jump, and I'm a little more than 1% of a failure rate. Okay, so that's a potential. Could cause deaths, right? So sometimes type 1 is more serious, sometimes type 2 is more serious, depending on which way you go. What my goal is that you also see is that we're always testing the HA, regardless of what the claim is. The salmonella claim came from HA. We still test the HA. So as you kind of see how these things work a little bit. All right, I bored you to tears on this, I know, but it's just